Hello, in this video I'm going to talk about repeated samples, or repeated sampling, and what that idea is all about, and we're going to do so using this app. There's a link in the video description. Before I actually get into it, I just want to really quick show you what it does for those of you who are familiar with this stuff. I can hit this go button and make data and make plots of statistics down there. I can have 4 samples, I can have 9 samples, I can have 2 samples. I can change the sample size between 2 and 10, and I can mess around with the population distribution. This is a beta distribution right there. So that's what it does. Okay, I'm gonna hit refresh and explain this properly. So to start off with, repeated samples or repeated sampling. This is a fundamental concept in statistical inference. It refers to the idea of taking what it says here, repeated samples, taking a sample and then performing some analysis on it, like computing a statistic, say like a mean or a standard deviation or a maximum, and then doing that again, and then doing it again, doing it again, doing this over and over and over again, taking repeated samples and then performing the same kind of analysis on them. And the idea is to see how the results of that analysis sort of behave overall. So I'm gonna hit go right here, and this is gonna create, up top, it's gonna create multiple or repeated samples of data. I've got sample 1, 2, 3, and 4. Well, over here on the slider, it says number of samples is 4. Each sample has a sample size of 3, so there's 3 data points in each sample. So here, there's like 1, 2, 3 data points. There's 1, and there's 2 right there. So this is an important distinction. I have 4 samples. I have 3 data points in each sample. Okay, and then on each plot for each sample, we have visualizations of these 3 different statistics. These vertical lines here are for the means, and if you sort of look at the data, like, hey, there's these 3 data points. Yeah, that looks like it should be about the mean. And, that's about the mean of those. These are shown again down here. So this plot down here is a plot where we take these 4 means and just put them all on the same plot. And you can see, like up here, this red one is the smallest of the 4 means. Well, there it is. I also have maximums. These are these dashed lines. The maximum is just the biggest value in a data set. And so you can see, like, there you go. There's the biggest value. It's right there. And there are my 4 different maximums. And then I've got standard deviations. The standard deviation is a statistic that tells you how spread out your data are. So these are visually, we're showing these horizontally. We're showing them coming from the mean, but you could put this anywhere. Like I could draw the standard deviation over here if I wanted to. It's horizontal because it's sometimes useful to think of these as like, it's like a length, a distance, a standard amount by which data points deviate from their mean. And down here I have the 4 standard deviations being plotted, and to sort of connect these 4 dots to what we see on these 4 plots. Here, all 3 data points are really, really, really close to each other. The data are not very spread out at all. And that teeny, teeny, tiny little standard deviation is being plotted right here. And it has a value. Its value is represented by the circle. And then the data set, or the sample of 3 that's the most spread out, is this one. And you can see on this one that standard deviation is much larger. And there it is right here. That line is drawn again. And again, I think it's helpful to think of a standard deviation as being like a distance, but it is a statistic with a value, and there is its value. Okay, so that's what's going on. What's the important stuff here? Well, the most important thing that I want you to look at is this distinction between data. If we were to look at these gray bars, these are all samples of data, and then plots showing values of statistics. Down the bottom, these are values of statistics. On the top, values of data. It's very important to make this distinction. Let's see. if we can get some other useful concepts nailed in here. Here I've got my distribution from which my data have came. This slider moves the bulk of it to the left. This one will tend to move it to the right. I know it's annoying that the one that says right is on the left and the one that says left is on the right. This is a distribution called the beta distribution, and that's just the order in which its two parameters are usually listed. Oh, here we go. This is a uniform distribution. If I bring those down, I'm going to increase the sample size. Let's make it be 10. Okay, so now each of these samples is of size 10. I have 10 data points. They came from a distribution that is flat, and so unsurprisingly, they tend to look kind of flat in here as well. I can take more. Let's take 9 of them. Okay, I have 9 samples, and so down here on the bottom, I have 9 means, 9 maximums, 9 standard deviations. Let's take a look at the behavior of this maximum. You can see these are all up here. Well, that should make sense. I took samples of size 10. The maximum is the biggest value in each sample, and so that tends to be up here on the right. Were I to decrease the sample size, let's bring it down to 3. Okay, these are way more spread out now. Here you go. That's the maximum value. What happened there? Let's see. Oh, there it is. Sample number 3. Look, I just so happened to get 3 data points that are on the left, and so the maximum value from that sample is way down here. Most of the other ones are much bigger. If I were to make this thing be right skewed, what I would see is that these maximums aren't all that big anymore, because that's the distribution from which my data came. I could maybe think about the distribution of means. Let's take this population distribution and make it look a little bit more normal. I'm gonna make my sample sizes bigger again. I'm just gonna grab 2 of them this time. Okay, 2 means. Let's grab 9 of them. Oh, these are clumping together. If you're familiar with this thing called the central limit theorem, it says that distribution of means should tend towards normal. Now, you're not really seeing a normal distribution here because I'm only taking 9 samples. There's a concept called a sampling distribution. And here's a little Wikipedia page on it. This is a very important concept. Here's its quick definition. If an arbitrarily large number of samples, each involving multiple observations, were separately used in order to compute one value of a statistic, like the mean or variance, then the sampling distribution is the distribution of values that statistic takes on. So these things down here at the bottom of this plot are kind of like sampling distributions, except I've only got 9 samples. A proper sampling distribution has lots and lots and lots of samples, thousands, millions. If we're in a theoretical math world, it's got an infinite number of samples. And if we were to take lots and lots of samples, I would see a distribution of means that maybe looks like this, and I'd see a distribution of standard deviations that maybe looks like this. But the point of this app is not to show you what a full sampling distribution looks like. The point of the app, again, is to make this connection between individual samples of data and collections or distributions of values of statistics taken from those data sets. When you see the word sampling distribution, it is very, very important that you make this distinction. The sampling distribution, we're not using sampling as a cute adjective here. It's referring to a very, very specific thing, a distribution of values that a statistic takes on under repeated sampling. Okay, I hope that was helpful. And if you want to see any more videos, I got a bunch more. You can check them out. Have a good one.